So again, if we pick f minus x is equal to negative x to the power of 4 minus 2 times negative x, which is equal to positive x to the 4 plus 2x, which is neither one of them really. It's not f of it's not minus f of x or f of x itself. Therefore, it's neither odd nor even. Okay, so if it doesn't fit either one, well then it's neither. Let's flow down now into our sums and products of functions. Really, it's just different notation here. We can add functions together, we subtract functions, we can multiply functions. Now, a lot of our course is really about identifying what the domain of this function happens to be. So the key is, if we're going to work with two distinct functions, both functions need to be defined all of the time, okay? So in other words, we have to have a common domain for both functions. So if we're going to add two functions, both f and g have to be defined, subtract them, multiply them, etc. So the domain of a product or a sum of functions is the intersection of the two functions themselves. So if we have a look at this example now, example 8, we can see the function f plus g. Well, that's just equal to the square root of x minus 1 plus the square root of 3 minus x. So nothing big about that. Tidy that up a bit. So f plus g of 3 is just substituting the function in, which is equal to the square root of 3 minus 1 plus the square root of 3 minus 3, which is root 2 plus root 0, which is simply root 2. fg is the product of the two functions. So that's equal to the square root of x minus 1 times the square root of 3 minus x. Now we could put the whole thing under one big square root sign there, but we don't gain a lot, so we can leave that, okay? And again, if we want to then work out the function at 2, we substitute 2 in. So the square root of 2 minus 1 times 3 minus 2, which is the square root of 1 times 1, which is simply 1. Interesting to note that if we wanted to find the domain for any of these, well, the individual domains, the domain for f is from 1 to infinity. The domain for g is from minus infinity to 3. So the composite, the domain of f plus g, sorry, the sum of them, or f minus g or f times g, the domain of f times g would be equal to what satisfies both. So it's got to be bigger than 1 but less than 3. So it would has to be bigger than 1 but less than 3. So that's the domain that satisfies the sum or the product of those two functions. If we want to have a look at another example now, we've got a function here, g of x. We've got to show that g of u plus v plus g of u minus v equals. So let's work out what g of u plus v is. So it's equal to u plus v squared. G of u minus v is equal to u minus v squared. So if we u squared plus 2uv plus v squared, u squared minus 2uv plus v squared. If we add them together, g of u plus v will get 2u squared plus 2v squared. What's that equal to? That's equal to 2 times u squared plus v squared, which is equal to 2 times g of u plus g of v, which is shown. Okay, so sometimes you don't know where exactly the proof needs to take you, but just start, expand the terms, group them together, and just see where you go. Okay, have a go at 1D.